Hello and welcome to this. Sorry about that. The microphone wasn't. Now it is connected. So here's our first in our series of questions students have sent in. Mainly going to be GCSE today. Well, actually all going to be GCSE today. And we're going to be looking at graphing inequalities and some sine, cosine and trig problems. Anyway, here's the first of our problems. I'll give you 2 minutes to mull it over and then I'll go through the question. You can see on the right the student, what they sent in done, and a bigger version on the left look at. So here's 2 minutes. Have a go and see where you get to. I go through it. Right, there we go. It's our first question. Hopefully you had a time to give it a good go. And the first thing we're going to do is we've got to identify the boundaries of this region and what equations it gives us. So here's this line here is where the y value is always equal to 2. So we've got the y value equal to 2 gives us this line here. Here we've got where the x value is equal to 0. Everywhere along here x equals 0. And then we've got these two equations to find here. Now we could know that, should know about y equals mx plus c, where m is the gradient and c is the y-intercept. We can see this is going to cross at -1. And for every 1 you go along, you go 1 up, so the gradient is 1. So we effectively have y equals 1, lot of x, which is just x, minus 1 is where we cross the y-axis. And then for this graph, we're going to cross at 2.5. So we're going to have y equals mx plus c. We know our c is going to be plus 2.5. And then we can see the gradient, it goes down 1 for every one, go down 1/2 for every 1 we go along. So the gradient is minus 1/2. Y equals 5. Now, to get the region, it's not enough just to write down the equations. We've got our 4 equations, okay, which give us the boundaries. We need to work out which side of them we're going to be on. So for the x equals 0, we know we need to be greater than 0. So our answer is x is greater than. And if we have a solid line, it's allowed to equal it. So we can equal. And then this one, we know that it's going to be the y value is going to be less than 2. So y is going to be less than equal to 2. And we can see our student has gone for y is greater than x minus 1. Well, a good way to test that is to choose a point not on a line. So how about 0, 0? It's not on this line. Okay, and we can see, does 0, 0 agree with that assumption? So is 0 greater than or equal to 0 minus 1? Well, it is. The only mistake that students made is it's not equal to, because we've got a dotted line, which means it's strictly greater than x1 and not equal to 1. And then on this last one, they've identified the equation correctly again. Have they got the right region? Let's put naught into this. So we've got naught here and we've got naught here. So the 2.5 is bigger than the naught, so it should point that way. They've got it pointing that way. Or if you want to guess the inequality and then put it in, is naught less than or equal to naught plus 2.5? Well, it is, except it's a dotted line again. So this needs to change to y is less than or equal to minus a half x plus 5. Okay, so don't see any questions in chat, so let's move on to the question. Here we have a tricky cosine sine rule problem and area problem. I'll give you 2 minutes to get started. It's unlikely you'll be able to finish it, but you'll get a good way into it and right direction. And if you want to have a go at it later, you can, what you do is you pause it. For the purpose of these videos, I want to just give you a chance to start it, then I'll go through it so you get some idea of whether you're going in the right. Solve these. Right, I know it'd be tricky to have finished this in 2 minutes. I think I would have struggled to do it in 2 minutes. But you should have a good idea of whether you may be going on the right lines or be able to compare your starting point to my starting point. So we know that BD is 11. So here to here is 11. BD. And what we can do is if we know this angle here, we can then find the area of this big triangle. And if we know this side, we can find the area of this small triangle as well with that angle. So therefore, that's going to be my plan of action. Find this angle and find this side, so I can find the area of the big triangle and the area of the small triangle using the formula that area is equal to half ABC is what I'm going to go do that with. So let's start off with this one. Yeah, so we're going to have a look at finding the whole of this angle to start with. Okay, and we can see that cos of theta, the adjacent over the hypotenuse, 5 over 15. So therefore, theta will equal verse 5 15. If I grab a calculator, you can go and have a go at some of them. So we do 5 divided by 30. function inverse cos of, and we get 67 degrees. That angle. So now we can find out this area. Let's that area. We can find out actually no. What I'm going to do next is I'm going to find out this angle here, x. Okay. Next, then I can find that, and then I can work on this side. Then do all the areas together at the end. Be a better plan. Do things in order. We can now find this x out. Because we know that side, we know that side, and we know that side, we can use the cosine rule to do this. So we know from the cosine rule a squared equals b squared minus 2bc a, where a is opposite this side. So this angle must be opposite this side. So this angle here, x, must be opposite the 12. So I'm going to have 12 here squared, then this 11 squared plus this 13 squared. Minus 2 times 11 times 13 x. Now if I rearrange that all, I can get cos x on its own. I'll let you do that as an exercise. You should be able to do this and get the same thing. What I'm going to do is take that to this side and then effectively have the 11 plus the 13 squared minus the 12 squared all on the top of the fraction, and I'm going to be able to divide by 2 times 11 13. So if I grab my calculator again, so fine. Have that on screen. So I'm going to do 11 squared plus 15 minus brackets from that. Fortunately, it's quite clever, this calculator. It realizes I wanted some at the beginning. Times 11, 15. And I get minus 4, 8, 9. Calculator, and I'm going to do inverse cos that. I get 92 degrees. That was what cos x equals 2.08. And I'm not just certain about it. I just want to check I've put the right numbers in the right place. And so just check I've got the right things in place and working. And I can see I've made a mistake back here. Now, I just had a feeling this isn't going to be 92. I can know it's not going to be 92 because all these numbers were very similar. So I've missed out the one there. And due to this calculator, it works everything through. So I can rub out my answers there. Got about 0.5 for here. And then for the other one, I've got 59.3. Being able to spot where you make mistakes is quite important. Having that feel for the numbers and knowing that there was something wrong. I had a feeling there was something wrong with this. 11, 12, 13 shouldn't come out close to 90. It should be coming out closer to 60 because it's not far off being equilateral. So I've got my x, I've got 59. And I've got my theta 67 degrees. Therefore, I can work out this angle here, y. Y will equal theta minus x. And that will equal, got here, 7. Let's just put it all into the calculator to keep all the accurate answers going. So we're going to have 67. Oh, sorry. Using the calculator. So we're going to have 67. Again, it's missing 50. Exact to get the answer. So what do we need? We got 8.0. So from that, I can now find this length here, BE. I'm going to working on here to try and So BE, this side here. Now I've got 5 over BE will equal cos of 1. So therefore, BE y. Now, rearrange that. BE will equal 5 over cos of a. Calculator again. 5. Answer be 5.05. So I now know this length here is 5.5. So I now can work out the area of this triangle, and I can work out the area of the big triangle. So my area of the big triangle of BDC will equal a half times that length there is 11 times this length here is 13 times sine of the angle here, which was my x value, which was calculator. 5 times there, 0.5 times by 11 times by sine of 50. Get 61.7. Now I'm going to do the area of, what is it, BEC. That's equal to a half times by that distance 5.5 times by calculator 5 times 5 sine, and it was the same angle, wasn't it? 28 sine of 53. So my answer is going to be, let's change the colour, it's easy to see, 61.47 minus 28.2. One point 2, and I get 33.25. I'm going to round that to one decimal place. So it's 33.321 decimal place. Quite a lot of working for that question, and not easy to do in 2 minutes. But hopefully you'd have worked out the same plan and got well onto the way to getting the same answer. And you can see a lot, the students, when they sent this in to me, had a lot of the right answers in there. There's a 59.3 there kicking around. Not sure about the 68.67, but just got confused as to where to get to the end. Anyway, next question. Okay, we've got a square is divided into 4 triangles. But the area of the triangle of region P is 8, and the area of region Q is 12. Find the sides of the 4 angles where the triangles meet at a point. But what I'm going to do is I'm going to go through the process when I go through it of just finding one angle. And I think the first angle I find is R. So see if you can find the angle for R, having found a pattern for triangles. Because once you've done that, you repeat that pattern to find the other 4 triangle angles. That would be enough minutes. Right, so here we go. So we've got the square 8 centimeters, so we know each side is 8 centimeters. And we know the area region P is 8. So therefore, if half the base times the height is equal to 8, so half of 8 is 4, times by 2 give us an area for P, region P as being 8. Now Q, we know that's 12, so 4 into 12 goes 3, so we know that has a height of 3. And once you've done that, we can see that this one also have a height of 6, take 2 away from 8, and this one must have a height of 5, take that away from 8. Now, so we're going to work out the angle here. So we can work out this angle here because we know that this distance is, and we know that this distance here is 3, and we know that this distance is 5, and so we can have this angle x, the tan x will equal the opposite over adjacent, so 5 over 6, and tan y will equal 3 over. So therefore, if x will equal inverse tan of 5 over 6, and y will equal inverse tan of 6. So x plus y, which is this whole angle here, will equal inverse tan of 5 over 6 plus inverse tan of 3 over 6. Grab our calculator. And what we get, so we got inverse tan of 6. Add on to that the inverse tan of 3 divided by 6 y. And we get 66 for this. And you can do all the other angles exactly the same way. So you know that this side here is going to be 2 and this 6. So you've got the opposite over adjacent, to get those two angles. And just go around repeating the process. So we've got 2 over 3 over 2, and you've got 5 over 2 here. And we know that this side's 2 and this 6, and you've got 2 over 5 and 6 over 5. And you just go around adding them all up. Actually, I've done the answers. So this one here comes. Then the next one's 7, 1, and this one 0. I think. Okay. So you can check your answers later. Right, let's look at the next questions. Go. Click on it. There we go. Our last question for today. The triangle is isosceles where AB equals BC. Lengths AB equals 12 and AC equals 21.48 centimeters. Find the angle of ABC and hence find the length CD. Should be a little bit more straightforward than last two to finish off. Okay, so last question. And to find the angle of ABC to two decimal places. Well, we know that this is 12. So again, we're going to use the cosine rule to find the angle C. So cos of AB 12 squared plus 12 1 point all over 2 times 12. So how about calculate make it a bit better? And we get 12 9 12 7 2 times, and we get minus rest, and then we do inverse cos. Answer, get 107.101. 7.6. So 2. Hence, find the length of CD. Find this length. So we've got that side, got an angle on a side, but we also have this angle because we now know that angle. So we've got another angle on the side, and we've got an opposite pair and then another side we want with an opposite angle, so we can use the sine rule. The sine rule, you need opposite pair. This angle here is going 180 minus 127. So we're going to get 52 point here. So CD divided by the sine of the opposite angle, 52.8, equals 12 over 5. So therefore, CD will equal 12 over the sine of 5 times by the sine of 52.8. Grab our calculator for one time. We can 12 sine 5 times sine 50, and that gives us 670.67 centimeters. To finish, that's the last question we're going to do for today. That's all sent in this time. If you want to send in some questions, feel free, and we'll go through them at the same time tomorrow.